Hello, I'm Aaron, and this is my Chapter 5 FRQ test corrections. And in the first one, we were asked to identify which vector represented the net force. And I got this one wrong because I thought that it was B, but this is actually wrong. So over here, we have two forces, mg and T. We correct T into the different components, Ty and Tx. And we could actually cancel out these two. That just leaves us with Tx going this way, and that means the answer is A. For B, we're asked to is the magnitude of the tension greater than, less, or equal? I thought that it was equal, but that's actually wrong, because since the Ty is equal to mg, that means that T has to be greater than mg because there is a component Tx. Since Tx equals Ty equals T, then that means it has to be greater than mg. And in C, we're told that the string can never be horizontal, no matter why. We're supposed to explain why, and I got this right because when you crack the tension, there always has to be a component X. And yeah, and that's why it can't be horizontal, or Ty. That's why it can't be horizontal. And then in part D, we're asked to indicate which equation is consistent with the statement in part C, and to explain why, and explain why the other one isn't consistent. So I thought it was the second one, equation 2, but that's wrong, because we're asked to explain why it could never be horizontal. So we know that when it's horizontal, it'll be 90 degrees. If we plugged in 90 degrees in here, we'll get GL times 1 divided by 0. And that is undefined, which means that is consistent with our reasoning, because it can't be 90 degrees. When we plug in here, we get P equals G times 0 divided by 1 is 0. And then our velocity can't be 0 while it's moving. So in part E, we're asked to find the graph. What's a graph? And I got this wrong. I said that we could graph E squared over L, and that would give us the right graph for G. And in part F, we're asked to determine if rotational inertia will decrease or decrease, or stay the same if L increases. So I only said that it would increase because the length increased, and since I is equal to mr squared, it will increase. But I forgot to say that since the mass is farther away, that it will also cause the rotational inertia to increase. So I only got 1 out of 2 for that part, and that's my test correction.